Bismillahirrahmanirrahim. We are going to start the training session in R. I will ask all of you to work completely side by side as I am doing some work here on my computer so that you will get the actual perception of what we are doing here. I want to keep the workshop as simple as possible. I don't want to mix the heavy contents in this workshop. So let me start by introducing the GUI of R. We first have to describe the GUI of R, what the R is. So let me share the screen of R. This is the GUI of R. This comprised on the 4 segments. The upper left corner is a script file. We call it as a script file. So this is our script. The bottom left screen is known as console. And this screen is an environment screen. It has the several tabs. We can see the history of the commands we type. We can see the connections and the tutorial window as well. So there are the 4 different tabs over this window. So we can click over any tab to get the required information. The bottom screen, we have a plot segment, which is very important. Okay? Every graph will be printed here. And similarly, we have the other tabs too. Files can be seen here, packages, help, and view, and so on. Okay? The graph is very important. So whatever we draw will be shown here. So these are the 4 different screens that we have in the GUI of R. Script is what? Script means we can type the commands here. The commands will be accumulated and we can run the specified contents by clicking this button. So just you have to select the commands. For example, I want to create random numbers. We create a series of numbers from 1 to 100. So I just wrote a code here. This is a R code. 1:100. The colon operator is a sequence operator. So what this will do, this will print 100 numbers on the screen. So the numbers will be printed in the console. So just select the command or click in the command. Both options are valid. Just click in the command and press run. So when we press run, you can see the output of the command on the bottom window. The 100 numbers will be printed in a sequence 1 to 100. If you want to store these 100 numbers in a variable or in an array, so you can just write down the name of the array here and type the assignment operator. So this is the assignment operator. In this assignment operator, what this assignment operator does, these 100 numbers will be stored in a vector named x. So if I run this command first copy into the console and then the output will be shown. But in this case, output will be what? Output will be a variable x. So output directly will not be shown here. Directly the output is stored in the variable x. And then we can print the variable x by just placing x. So what x is, x shows the content of the variable x. So I'm just running these 2 commands. I'm running the first command, then second command separately. The first command did what? Only the one line is there, and that line is 100 100 numbers are stored in a variable x, but these numbers are not represented in the output window. If I run the second command, there is nothing in the second command, just place x, which shows all of the 100 numbers which are stored in the variable x. So we can create a vector of array by just this assignment operator. So this is a very simple way of storing data. If you want to find out the way descriptive measures, what the descriptive measures are, for example, you want to find out the mean of all of these 100 numbers. So just write down here mean of variable x. You can also write down this command as mean 1 colon 100. The both of the commands did exactly the same. In this variable x, all of these 100 numbers are stored. And what I am doing here, I am doing the 100 mean of the 100 random numbers. So just you click and 50.5 is the mean of these 100 numbers. If I run the first command, which is the mean of x, so you can again see the 50.5 is the mean of the variable x. If you want to find out the variance of variable x, so you have to just write down var and place the variable x inside it. If you place the variable inside it, the variance will be printed. The variance of this variable is 841.66 is the variance of this variable x. It means the variance of first 100 natural numbers. If you want to find out the standard deviation, we just calculate SQRT. SQRT is the function which calculate the under root or the square root of the variable VAR and the X. So what this does, this calculate the variance first and then a square root of this variance means the standard deviation. You can store this standard deviation in a separate variable like S, because this standard deviation is a sample standard deviation. Therefore, we can see that uh, S will be calculated here. In this case, the output will not be shown directly. If you want to show the output, just write down S and run. So standard deviation is 20.9 and the variable is variance is 841.66. So this is the way of simple working in R. If you have any of the question related with the material delivered in these few minutes, so you can now raise the question. Your question, please. If you want to take the help of any function, the entire software is basically bifurcated into the two parts. One is called the core software, jise we can call it as core R, and the other things are the libraries. Some of the functions are available in core R and the rest of the functions are available in libraries. For example, if you want to use a library for visualization, the main name of the library is called ggplot. So ggplot is a library which help us to display the variety of graphs by using this library. Okay? So there are the few of the graphs that we can print by the core R, but if you want to use the extended graphs, these extended graphs are available in the library ggplot. So how to include the library into your core R? Core R functions are directly available. For example, if you want to make a histogram of the variable x, so just write down hist and x. The histogram will be printed. So this is the histogram. Because the numbers are uniformly distributed, so the distribution of these random numbers are just a uniform distribution. So you can see the uniform distribution here. But if you want to draw 1000 random numbers, okay, your objective is what? Your objective is to draw 1000 random numbers. So random numbers can be drawn by.
सर स्क्रीन शो नहीं हो रही है आपकी जिस पर आप शो काम कर रहे हैं.
Okay. If you want to draw 1000 random numbers from a normal distribution, so your command will be what? Your command will be y assigned to R norm. R norm is a function which draw the random numbers. How many random numbers you want to draw? There are the three parameters in this function. One is n, other is mean, and the last is standard deviation. So n means how many random numbers you want to draw. Suppose I want to draw 1000 random numbers. These random numbers are drawn by a normal distribution having any mean. Suppose I am talking about the mean 50 and the standard deviation 5. So these random numbers drawn and stored in the variable y, If you want to make a histogram of y, so you can expect this graph will not be uniform like the previous graph shown on my screen. This graph, can any one of you predict what type of graph this will be? So obviously, this is the graph of a normally
Normal distribution.
right? So I am just printing the graph here. So you can see that these are the random numbers, and but the graph is not as random as I was expecting. The reason is, I think मैं mean और variance इसका change करके देखता हूँ. Mean is 0 and the variance is 1 because that distribution will be called the standard normal distribution. Now you can see that the normal distribution with the mean 0 and the variance 1, the shape is exactly as we were expecting. If we want to draw the random number as maximum as possible, suppose we want to draw the 10,000 random numbers and these random numbers are stored in Y. So you can see that the graph will be how the graph will be changed. You can see the graph will be very precise and compact as compared to the previous one. So you can draw the random numbers from any distribution and you can make the graph of that, right? So this is the simple logic that you can apply. I draw how many random numbers I draw? I draw 10,000 random numbers. What is the mean of these random numbers? 0. And what is the standard deviation of these random numbers? 1. So now I am checking the mean and standard deviation of y. So in a simple way, mean of y, you can see the mean is very closer to the 0, but not exactly. Similarly, the standard deviation or the variance of y, as you expect, it is closer and closer to 1. So it is 1.00046. So if I extend the sample size, suppose instead of 10,000, I am drawing 100,000. So these means and the variance will be more closer to the 0 and 1. Now you can see that histogram of 100,000 random numbers, it is closer and closer to 1. It is closer and closer to the 0. So this is the way to draw the graph into the core R. If you want to add a library, as I told you, you can add any library. Suppose if you want, but the libraries are basically the part of extended R. So in advanced, if you want to enhance the R features at advanced level, so you can add specific libraries. I am just mentioning how to add the libraries in R. So the command is in tools, install packages. That is the first option. Your internet should be connected, and now you have to mention the name of the library you want to install. As I told you, the ggplot. So if I just place a G, so there are the several libraries which are starting by G. My specific library is ggplot. ggplot ggplot2 is a library, right? So you have to just write down the name and click on the install button. The library will be installed. You can use the extended features of the ggplot2. What the extended features of the ggplot2 are? The graphs are very fine, and the several types of graphs can be drawn by this library. So I'm not adding this library right now, but I just gave you a concept. Okay, how can you add the libraries into the core R? Now, the main thing in R is how to uh, read a data file which is in CSV format. So I am downloading a one file here, which is already shared to you. The name of the file I am mentioning here, the name of the file is West Roxbury. This is the name of the file. West Roxbury is the name of the file. This is a CSV file. All of you have already shared this file to you, so you can load the data file into your R session yourself. Now click on the R script and write down a command read.csv. Read.csv is a command by which we can download a CSV file into a R session. Suppose this data file contains the house prices. So I just write down a name house here. Okay? Or you can write down as simple as possible H price. Or we can write down any simple name as HP, house prices. Now you have to mention the name of the file in the bracket. And the name of the file is, as I told you, the name of the file is file West Roxbury. Copy the path to the clipboard and just write down, paste. Right? You have to mention the complete file path and the complete file name. Just copy the path and the file name from your Explorer window and paste the complete path and complete name of the file along with extension here. This file name should be provided in a way string, means it should be closed in the double quotes. Now, one thing you must have to change, and that thing is this file is already shared to your WhatsApp groups. So one thing you must have to change, and that thing is backslashes are valid in Windows, but in R you must have to change it as a forward slash. So you have to change the path name by forward slash. So this file is stored in my downloads folder. So from the downloads folder, this file will be readed here and stored in the variable HP. Just run this command. And after the one prompt line to the another prompt line, if the arrow is clearly mentioned over there, that is an indication that this command has been successfully run. And the file HP is stored in now my computer. So the file HP is stored here. You can see the file HP here on the environment variable. You can see at the top right on the screen HP, how many observation it has? It has 5,802 observations of 14 variables. So this is the file in which we have approximately 6,000 observation in 14 variables. You can see the complete structure of this file. So you have to mention the few of the commands. One of the command is strhp. What strhp does? Strhp show you the structure of the data file HP. Now I am executing this command. If I run this command, so you can see the several lines here in the console window. So what type of file is this? It is a data frame. So R is referred to this file as a data frame, and the structure of the file, how many observations it has and how many variables it has. It has 14 variables. What these variables are, as I told you, this file contains the prices of the household sold in a specific US city. So now the variable are total value of the house, tax over that value of the house, lot size, how many, what are the dimensions of the square, in square feet, how much is the area of the house. Air built, this is the air gross area, how much is the total area, living area, number of floors, 2 floors, 1 floor, and the number of rooms, number of bedrooms, full bathrooms, how many full bathrooms it has, half bathrooms, and number of kitchens, fireplace, and remodel. So these are the different types of variable we have in this data file. These are approximately 14 variables. Some of the variables are integer, some of the variables are numeric, but one variable is there which is of type character. In R, the character variables is also referred to as factor if it is in categories. So as we have here the few of the categories here. Remodel means it is refurnished. Whenever it is refurnished, recent, none means those house which has not been remodeled is none. But if it is remodeled recently, then it has a value of recent. Now you can convert the last variable. You can convert the last variable as a factor. So you have to write down the factor as HP is the name of the data frame, and the dollar sign. If you place a HP dollar sign, so you can see that all of the variable names are there. So which variable I want to convert as a factor? The name of the variable is remodel. Just place remodel. So you can see if I just click enter here, so you can see all of the possible values what this variable has. None, recent, old, and I think these are the few values which we have in this variable. Now I want to convert it in factor. So what is the command which we have to mention here to convert this variable into the factor? I am just write down this command into the script. Control V, and the command is factor. Factor means categories. Character means the string or the alphabets. So it is in the alphabetical order, but now we want to make it into the categorical order. Where I want to store this variable, converted variable, so I want to store the same remodel variable again. So on the right side, I have a remodel variable. On the left side, again, we have a remodel variable. In between that, we have a factor function. So what it does, it convert the HP remodel variable into HP remodel again. And now the data frame will be mentioned here again. Remodel, HP remodel. Now you can see that HP remodel, the same things are there, but instead of double quotes, now we have without quotations. Now we can see the structure of the entire data frame by the same command strhp. In the strhp, now you can see that the last row, it is now a factor variable. How many levels it has? It has 3 levels. What the first level is? None, old, recent. It means it has only 3 values: none, old, and recent. Other than we can print the frequency distribution of this remodel variable. So there is a command which is the table command. table command, I'm just using the table command in script as compared to writing it in console directly. Your command is table command. It is in small letters. Table command. And the table command HP dollar remodel. Just press tab button. Now you can see this frequency table. This frequency table is indicating that we have was variable remodel. The first value is none. Second value is old. And the third value is recent. Recently, it is remodeled. 875 houses were recently be remodeled, and 581 houses very far they were remodeled, and there are 4,346 houses which are recent, which never been remodeled, right? So this is the way of making the frequency curve into frequency distribution into R.